Hey everyone, welcome back to SmartSlides. In our last video, we talked about the basics of dimensional modeling, fact tables, dimension tables, and how they work together to make data analysis easier. If you missed that, go check it out because it's a great foundation for what we're diving into today. Today, we're going to explore the next level of dimensional modeling, schemas. These are the blueprints that tell us how to organize fact and dimension tables in a way that makes sense for your business. Specifically, we'll break down three types of schemas: Star, Snowflake, and Galaxy. By the end of this video, you'll know exactly which schema to use and when. Let's get into it. So first off, what even is a schema? Think of it like the game plan for how your data warehouse is set up. It's basically the rules for how fact tables and dimension tables connect to each other. Now, there are three main types of schemas we're going to talk about today. Star schema, super simple, super fast. Snowflake schema, a little more complex, but saves space. Galaxy schema, the big leagues, when things get really interconnected. Let's start with the easiest one, the star schema. All right, so picture this. A single fact table sits in the middle, like the heart of the system, and it's surrounded by dimension tables, like points of a star. For example, let's say you're tracking sales. Your fact table might store things like revenue, quantity sold, or discounts. And then you've got dimensions like who made the purchase, customer dimension, what was purchased, product dimension, when did the sale happen, date dimension. Here's the cool part. Each dimension is represented by just one table, and those tables aren't normalized. They're flat and easy to work with. This means fewer joins and faster queries. Now, why does this matter? Imagine you're running a small business and you want to quickly find out how many red bikes were sold in California last month. With a star schema, you can get that answer fast because everything's connected directly to the fact table. No complicated chains of joins here. Simple, right? Now let's talk about the Snowflake schema. Think of it as a more detailed version of the star schema. Instead of keeping all the dimension data in one flat table, the Snowflake schema normalizes some of the dimensions, breaking them into smaller related tables. For example, instead of having one big location table, you might have separate tables for country, state, and city. This reduces redundancy and saves disk space, something that's really helpful when you're dealing with massive data sets. But here's the catch, because now you have more tables, your queries will involve more joins, which can slow things down. Plus, maintaining a Snowflake schema requires a bit more effort since you're working with more lookup tables. So, who should use a Snowflake schema? It's perfect for larger organizations with complex data needs, where storage efficiency matters more than query speed. To sum up the differences between Star and Snowflake schemas, think of it like this. Model simplicity. The Star schema is like a cozy little solar system. It's straightforward and easy to work with. The Snowflake schema, on the other hand, is more like an entire galaxy with layers of detail. Storage efficiency. The Snowflake schema shines by reducing redundancy through normalization. But if you're okay with a bit of extra storage, the Star schema keeps things simple. Query performance. Star schemas are faster for small datasets because there are fewer joins. Snowflake schemas handle larger datasets better, but at the cost of slightly slower queries. So, which one should you choose? It depends on your needs. If you're focused on quick metrics analysis, like finding revenue per customer, the Star schema is perfect. But if you're doing deeper dimension-based analysis, like counting customers by region, you might prefer the Snowflake schema. Finally, let's zoom out even further to the Galaxy schema, also known as the fact constellation schema. If the Star schema is like a single star and the Snowflake schema is like a cluster of stars, the Galaxy schema is like an entire universe of interconnected stars. Here's the deal. A Galaxy schema contains two or more fact tables that share common dimensions. For example, a sales fact table and an inventory fact table might both link to a shared date dimension. Galaxy schemas are fully normalized, breaking dimensions into separate tables based on hierarchy levels. They're ideal for organizations dealing with highly complex data relationships. However, they require careful planning and maintenance, so they're not for beginners. So how do you decide which schema to use? Here's a quick guide. Small to medium data sets, go with the Star schema. It's simple, fast, and perfect for most businesses. Large datasets with storage constraints. The Snowflake schema is your friend. It reduces redundancy and saves space, but comes with a bit more complexity. Highly complex data relationships. If you're juggling multiple fact tables and shared dimensions, the Galaxy Schema is the way to go. Remember, there's no one-size-fits-all solution. The key is to match the schema to your business needs. All right, now that we've covered schemas, let's talk about how to actually build a dimensional model. It's not as complicated as it sounds. Just follow these 5 steps and you'll be good to go. Step 1, identify the business process. First up, you need to figure out what you're trying to analyze. Are you looking at sales data, marketing campaigns, HR metrics? This is called the business process, and it's super important because it sets the stage for everything else. For example, if your CEO wants to track sales performance across different regions, then sales is your business process. Make sure you have clean, reliable data for this process. If you don't, you're going to run into problems later. Step 2, identify the grain. Next, you need to decide how detailed your data will be. This is called the grain. Think of it as the level of zoom. You can look at data daily, weekly, monthly, or even down to individual transactions. For instance, if you're tracking sales, your grain might be line item per order. So every time someone buys something, it gets recorded as one row in your fact table. The key here is to go as granular as possible because it's easier to aggregate data later than to break it down. Step 3, identify the dimensions. Now it's time to figure out the dimensions, the who, what, where, and when of your data. These are the descriptive details that give context to your numbers. For example, if you're analyzing sales, your dimensions might include who, customer info like name, age, location, what, product details like category, brand, price, where, store location or region, when, date and time of the sale. Dimensions help you slice and dice your data however you want, so spend some time getting these right. Step 4, identify the facts. Once you've got your dimensions sorted, it's time to focus on the facts, the actual numbers you're measuring. These are usually things like revenue, quantity sold, or profit margins. The key here is to make sure all your facts are at the same grain. For example, if your grain is line item per order, then every fact in your table should relate to that level of detail. No mixing daily totals with individual transactions. That'll just confuse things. Step 5, build the schema. Finally, it's time to put it all together and design your schema. This is where you decide whether you're going with a star schema, Snowflake schema, or Galaxy schema. And there you have it, a deep dive into star, Snowflake, and Galaxy schemas. Whether you're keeping things simple with a star schema, optimizing storage with a Snowflake schema, or tackling complexity with a Galaxy schema, the goal is always to make your data easier to analyze and act upon. If you found this video helpful, don't forget to hit that subscribe button and turn on notifications so you never miss a new upload. And if you have any questions or topics you'd like me to cover next, drop them in the comments below. I'd love to hear from you. Thanks for watching, and until next time, keep exploring. See you soon.